Hello, everyone. Thank you for joining us today. I'm going to give folks just a few more minutes to log in and join us in the presentation. So we'll be starting very soon. All right, I see a lot of you have joined. I'll give you just another 10 seconds and then we can get started. All right, if you don't mind, go to the next slide. Thank you. Well, all right, so hello, everybody. Welcome to the 2022-2023 Better Buildings webinar series. This is an annual series that was created to bring you the latest actionable insights from leading industry experts. And it's also a chance to explore the topics, technologies, and trends that affect your organization, as well as efforts to accelerate decarbonization and energy efficiency adoption. Next slide, please. Oops, sorry. Can you go back one? All right. So today's webinar is called ABCs of Multifamily Electrification Strategies. But before we dive in, there's just a few housekeeping points that I'd like to cover. First of all, please note that today's webinar is being recorded and it will be archived on the Better Buildings Solution Center. Once that's up, we'll follow up with an email to let you know where to access that link and where the slides are available. And the next thing to note is that as an attendee, you are in listen-only mode, meaning that your microphone is muted. So if you experience any audio or visual issues at any point during this webinar, please send a message in the Q&A box located at the bottom of your Zoom panel, and we'll be able to assist you there. All right, next slide, please. So today, we'll be using an interactive platform for Q&A and polling. It's called Slido. So what I ask you to do now is to either on your mobile device or on a different window in your internet browser to go to www.slido.com. That's SLIDO. Once you join that website, it's going to prompt you for a code. That code is DOE, as in Department of Energy, DOE. And as soon as you put in that code, the screen will come up where you can ask us questions. And you can submit questions at any point during this presentation. And we'll be answering the questions towards the end of the webinar. Now, the really cool thing about Slido is that you can upvote other people's questions. So you can, if you find questions there that you find are interesting, or if you have a question but you see that it's already been asked, what you can do is give it a thumbs up and you kind of bring it to the top of the list, which will help us prioritize which questions to address first at the Q&A stage. If you have any issues with Slido, send us a message in the chat box, and we'll take a look at that, try to help you out there. All right, next screen, please. So what we're going to start with is a little poll just to get us warmed up and see, kind of learn a little bit more about you and your experience with electrification so far. So if you haven't yet, please go ahead on to slido.com, type in that DOE code, and just pick your answer to this question. Please rank your current understanding of multifamily electrification strategies. I see some answers coming in. I'll just give about 30 seconds for the answers to come through. Seeing a pretty good mix here. This is ABCs of multifamily electrification strategies. So, you know, it is, if you don't come with a lot of background, you know, don't worry, this is perfect. We'll be kind of catching you up very soon. All right, great. Well, thank you so much for your answers. We are very glad that you were able to join us today. If you don't mind going to the next slide. So right now, I'll kick it over to your moderator for today, Josh Geyer. Welcome, Josh.
Thanks, Alex. So yes, my name is Josh Geyer, and I work in the office of HUD, the HUD Office of Environment and Energy. I am the multifamily sector lead for the Better Buildings Initiative, and I support the implementation of HUD's Climate Action Plan. Next slide. Before I run through the agenda and introduce our panelists, I want to give some basic background on why electrification of multifamily housing, including affordable multifamily, is a fundamental not only to decarbonizing the building sector, but to doing so as affordably and resiliently and equitably as possible. So building electrification is the process of shifting away from appliances and building systems equipment that burn fossil fuels like gas, oil, and coal toward all electric technologies. Electrification is fundamental to achieving the Biden administration's climate goals, including reducing economy-wide greenhouse gas emissions by 50 to 52% by the year 2030. 20% of total greenhouse gas emissions in the United States come from residential energy use. The emissions reductions we need to accomplish in this decade cannot happen without shifting away from dirty fuels to electricity, which together with a cleaner and more resilient electrical grid will facilitate our eventual transition to 100% renewable energy in this country. In addition, electrification has multiple additional benefits, including for residents of multifamily housing. Firstly, electrification investments mean more opportunity to increase resiliency through the addition of on-site renewables and energy storage. They also, when paired with, as they should be, with investments in increased energy efficiency of buildings, they reduce overall energy demand in our buildings. So when disasters happen and there are interruptions to power, that there is less power needed to maintain health and safety and comfort in buildings until that power service is restored. So the other thing, and folks may have been aware of recently, there's been some talk about the dangers of gas stoves and the types of pollution, indoor pollution that they cause. By eliminating combustion appliances in our homes, electrification can create healthier living spaces. You should also note that for equipment like HVAC equipment or hot water heating that is gas fired, while it vents outside the home and not into the home, the amount of global warming gases and smog producing gases that are produced by those appliances is staggering. It's actually, I know in California, where I live, the smog producing gases from appliances are more than those produced by vehicles. Just think about that for a second. Eliminating combustion creates healthier indoor and outdoor environments for people. So when we talk about then equitable and affordable transition, which is really important for HUD and for the folks that we serve, natural gas costs are projected to continue to rise substantially over the next decade due to unstable supply and increased demand worldwide. While electricity costs are also projected to rise, their increase will not be as steep. And importantly, the globalization of the gas market means that domestic gas prices will continue to be influenced by global supply shocks and insecurity, while we'll have more homegrown renewable electrons every year to stabilize electricity prices. And those electrons cannot be shipped abroad. It's also, electrification is also crucial for helping low and moderate income tenants avoid a gas price spiral, as fewer and fewer customers are stuck supporting the maintenance of gas generation and distribution infrastructure. Fortunately, policymakers have taken action and provided more carrots and sticks for to help building owners move towards undertaking electrification. So states and cities have begun to set their own standards for emissions and the electrification of buildings. These are building performance standards. They've been adopted in many places with deadlines in between 2035 and 2050, and more coming online every day, which will definitely move property owners to be taking this much more seriously and much more urgently. Also, as hopefully everyone knows, New fundings, rebates, and incentive opportunities are available through the Inflation Reduction Act and the Bipartisan Infrastructure Law, which will make electrification more cost-effective than ever. Next slide. So in today's webinar, we will cover the ABCs of electrification and beyond. We'll start with a brief introduction to multifamily electrification. So what's involved, which building components should be addressed, and what are the main solutions and lessons learned. We'll then dive into the scope of an electrification and be introduced to a new online tool that can help owners understand the right level of investment for their buildings in electrification. Next, we will look at some real-life examples of multifamily buildings that have been retrofitted to all electric systems, looking at upfront costs, changes to the operating budget, and the impact on carbon emissions. We will also learn about what electrification means for its end users, including residents, property management, and maintenance staff. Afterward, there will be some time for panelists to discuss questions submitted by attendees. As just to echo what Alex said, remember to please submit your questions via Slido. I'm using the code #DOE. You can submit questions at any time during the presentation and upvote the questions you think are the most helpful, and we will answer as many as we can at the end. Next slide, please. We have a great lineup of presenters today. And I'll introduce them all now. So our first speaker is Wes Stanhope. Wes is founder and CEO of Building Evolution Corporation and has over 18 years of leadership experience with commissioning, construction, facility conditions assessments, electrification, deep energy retrofit, and energy management projects. Wes has successfully assessed, advised, and commissioned buildings, both those with significant deficiencies and those with ambitious performance goals. Wes is a certified commissioning professional, existing building commissioning professional, certified passive house consultant, certified energy manager, and holds an unrestricted CSL. Our second speaker will be Brett Webster. Brett is a manager in the Rocky Mountain Institute's carbon-free buildings practice. He leads a portfolio of R&D analysis activities focused on catalyzing the market toward a highly scalable model for zero carbon retrofits to multifamily buildings. Brett also works on grid interactive buildings and communities, exploring how distributed energy resources and demand flexibility can provide grid services and support increased renewable integration. Before joining RMI, Brett worked at Energy Solutions, where he worked on energy and emissions modeling, microgrids, building energy design and simulation, and bus fleet electrification. He holds an MPP degree in energy systems and policy from UC Berkeley. And our final speaker will be Jackie Montestioca. Jackie is responsible for managing equitable building electrification strategies, including developing and implementing retrofit projects in coordination with technical teams across the organization, which is Elevate. Prior to her current role, Jackie worked on Elevate's national strategic and engagement and technical services teams, specializing in technical assistance, project management, and residential program design and implementation, serving both subsidized and naturally occurring affordable housing. She has managed a variety of projects, grants, and staff working on energy efficiency and resiliency across multiple states. Thanks to all of you for being with us today. Next slide. And with that, I will hand it off to Wes to kick us off. Wes?
Thanks, Josh, for that great introduction. So I won't introduce myself again. I'll take up time from that, but if you want to go to the next slide. I'm going to do a little introduction here to electrification. And I'm glad I have about 3 hours for this because, you know, I kissed that Blarney Stone twice, and many say I didn't need to kiss the first time. But no, we'll try to keep this down to about 10 or 15 minutes on this introduction to electrification, which is a little bit tough because there's a lot to learn about electrification, the do's and don'ts, and how to actually make it work for buildings. But if we're going to get through some of the basic information here from lessons learned on projects. So if you go to the next slide. And this is one of the actual projects that we were called into after a building had been operating for about a year. And this is a project that was electrification. This is a project that is a residential building. And we're looking at the photograph here is an actual ERV and electric resistance heating. The building has one-to-one heat pumps inside there for heating and cooling each apartment. So what could go wrong? The building's electrified. Well, in this case here, the actual ERV, this building I will set back, is in the Northeast. We have cold climate in the winter. And if you have electric resistance for heating after the ERV, and you are controlling that ERV by thermostats in the corridors, so you're using that ERV for space conditioning, then if you are setting that thermostat, say, for 75-degree space temperature, that electric resistance is coming on a lot. And in this case here, the electric bill for these ERVs is about $15,000 a month. It was actually overheating apartments, which are then going into cooling mode. And you're having simultaneous heating and cooling, not the type you want for heat recovery in a building, but type that costs a lot of money. So there are lessons learned from projects that might implement electrification that could go wrong if it's not implemented a smart way. So if we go to the next slide. So let's look at how do we learn a lot of lessons on buildings, and then how do we apply that to electrification? Well, we do a lot of assessments on existing buildings. Most buildings are already built. We know that. We're usually living or standing in them. And many buildings develop issues or problems over time. And we could look at those buildings, our existing building stock, and we could apply a business as usual approach to those buildings when the components come to end of life. That's the enclosure, all the mechanical, the electrical, the plumbing equipment inside there. Every aspect of a building has a lifespan. And when it comes to the end of life, we could replace what's there. You know, the boilers to be replaced, domestic hot water heaters that are natural gas or oil or propane could be replaced in kind. Windows could be replaced in kind. But that does not necessarily fix the issues or problems that the owners or occupants are having. So if you go to the next slide. Well, we can use those replacement time periods as opportunities to improve the building, and it's incremental improvements over time, where we can improve it for the enclosures, where we could use site-built improvements, where, you know, that's where you say the cladding has to be replaced in the building. Then you could do exterior insulation and then cladding over it, or a panelized approach. And the same thing where the MEP, when the boilers come to an end of life, well, then that's the time for, you might look at doing the electrification to a VRF or heat pumps. When exhaust systems need to be replaced, there's times for looking at ERVs. This is all very high level right now. We're going to get into actual individual approaches for these, but looking at the owner's goals and what are the driving issues that are having problems in buildings, there's usually ways to overcome these issues. We learn a lot from existing buildings, and we could apply that to the retrofits and to new construction. So if you go to the next slide. One of the things that's key on buildings, and especially with electrification projects, is the ventilation. We need to ensure that the ventilation systems are dedicated for the indoor air quality. They're separate from the actual space conditioning systems. So going back to that example I discussed at the opening slide, where the ERV was also doing space conditioning of the corridors, ventilation
ventilation should not be doing the actual heating or cooling of the actual space. The ventilation should just be tackling these outdoor air requirements and the exhaust. And it should have a conditioning system in it. So in the bottom right photograph, you'll see a DX coil. That's from a heat pump. That's for conditioning the ventilation air, to temper it, to cool, to heat, and to dehumidify the air, reduce the moisture content, but it is not for actually conditioning the space, where you have to separate the mentality of the two systems. You have a heating and cooling system for your space, and you have a ventilation system for your building. Next slide. And the actual system for ventilation needs to supply the air to the occupied spaces. Where people are requires the actual ventilation air, and it should be the appropriate amount of air to that space. So not supplying air to corridors or dumping it into a large amount of air to one area in a unit. It's appropriate amount of air balanced to each location where people are occupied, and then capturing exhaust air at the source and getting down to the appropriate amount of air for each space. Go to the next slide. One of the key things is to dehumidify the actual air. As buildings become more high performance, the humidity load of the actual ventilation air represents the highest aspect of the moisture content in the building. So the ventilation is the humidity load of the building. So, highest aspect of the humidity load building. So we need to actually tackle humidity at the source. So the actual ventilation air needs to be dehumidified coming into the building. This is an example of a building that was constructed without conditioning of the ventilation air here in the Northeast. And we were called in to take a review of what was going on. Well, we knew what was going on, but we did an assessment of it to just confirm it. The air is hitting, the moisture-laden air is hitting dew point and condensing on all the surfaces. It is key to actually dehumidify the air when we start to get to high performance, and the actual systems need to tackle that at the source, at the ERV, and having a high efficiency ERV to tackle that load. Next slide. The other thing that we see in a lot of the buildings is that the electrification is put into buildings where the enclosure might not be upgraded. Now, this was a project that we worked on where I don't think that do not enter sign necessarily works for keeping the air and thermal load out of the building. The VRF systems were put into a building and the windows were upgraded, but the rest of the enclosure was not. A lot of thermal bridging, air leakage, and lack of insulation. And what occurs here is that you still have a lot of solar heat gain to the building, a lot of losses, and the VRF system will try to compensate for that. And it does cause some comfort concerns. It can be done over time, where you could put in the VRF to tackle the cooling load and then come back and tackle the enclosure. But it needs to be looked at over a staged approach over time to be able to tackle the whole building holistically. But it is better to look at the enclosure before taking on the actual VRF system inside the building, if you are looking at the VRF. Next paragraph. Sorry, next slide, sorry. This is a project where it tackled the actual enclosure during the actual heat pump upgrade. This one did a ventilation and heat pump upgrade and took the actual brickwork down. There was a reason why the brickwork had to come down, but also did a deep energy retrofit to tackle the enclosure to take down the thermal load on the building and improve the air barrier, and to add ERV ventilation and heat pump for heating and cooling within the building. Next slide. And here's how it's turning out. This is a 281 unit multifamily building here in the Northeast. It's just wrapping up construction. It is going to represent about it's a 60% reduction in EUI by the end of, from start to finish. And then the solar is going to offset some of that EUI as well. Next slide. Not all deep energy retrofits and or electrification needs to go as far as the previous slides we saw. This is a simpler version where you're tackling the enclosure to bring down those loads to get to a future electrification project. This is one where the siding had to be replaced, put 4 inches of insulation to the exterior, and then do your installation. That allows for that EUI for the load, the heating and cooling load, to be reduced. Once it's reduced, it is a lot easier to come back for the actual heat pumps or other type of technologies to tackle that heating and cooling load inside that building. And now you have less equipment, less costs for construction. Next slide. There are different types of equipment that you could use. Typical ones we see on buildings is the actual one-to-one heat pumps like you see on the left, and VRF. We would prefer to have the actual branch controllers or branch selectors that allow for heat recovery between units, more for comfort inside buildings versus heat recovery. But these are very common. But if you go to the next slide, we've had Mitsubishi work with us on developing HEX and bring that to the market, where you have the VRF to heat exchangers that use hydronic to go into existing buildings with condenser loops. It allows whole buildings to have heat recovery, and that heat could actually go to other sources such as heating pools for YMCA projects or other buildings. And it allows for larger buildings or historical buildings to have larger systems that VRF could not actually work in for electrification. Next slide. And geothermal is another option that could be used, but it's also more expensive, and some site constraints cannot work with it. Next slide. This project here is one where electrification was required, but also we had to bring down the sound and the visual impacts. So sound attenuation and the VRF equipment was actually hidden, and to bring down the actual impact of VRF. So it could be actually in electrification could be brought into nearly any type of project setting. Next slide. That same project, the meter data before and after, to go from oil and electrical for cooling to all VRF was a 34% reduction in metered energy. Next slide. Options for domestic hot water include central systems, such as the QHV, which could replace entire central systems within buildings. Or if you go to the next slide, you could use the actual 80-gallon heat pump tanks, which could be either one apartments or semi-decentralized, attacking a few apartments at a time. Next slide. And here's just to kind of wrap up. I hear a lot where people say where old buildings cannot use, heat pumps or electrification projects. This is Care Castle, built in the 13th, 15th, and 17th century over in Tipperary. And you see in the top right, there's a heat pump condenser units for conditioning inside this 17th century section. And if you go to the next slide, this is Holy Cross Abbey. And it's hard to see on the outside, but on the parapets, there are Mitsubishi condenser units that are wrapping around the condensers, so you can't see them. But on the inside, they're actually space conditioned by the VRF fan coil units. I know this building well because I got married inside there. Next slide. And just some few lessons learned. It's important to have to know the interaction between the enclosure and the MEP systems. It's going to impact your projects. Ventilation is a very high load. You have to tackle that dehumidification. And basically, heat recovery is required both for ventilation and for the actual thermal system inside the building. And some of the key ones at the very end is that energy savings will not sell your project. It's got to tackle all the other problems within the building too. Let's look at everything holistically. So if you go on to the next slide, and I'll pass the baton on to the next presenter.
Great, thanks so much for that wonderful introduction, Wes. All right, next slide, please. Excellent. So hi, everyone. It's a pleasure to be here. I am Brett Webster with Rocky Mountain Institute, and I'm going to talk about an upcoming report we are about to publish under the Advanced Building Construction Collaborative that is aimed at providing some guidance to industry around the right approach. Given all of these considerations that Wes just laid out, how do we think about the right approach to decarbonize and electrify existing buildings? And I think one of the main takeaways from this report is to help shed some light on the question of how much investment in the building envelope needs to accompany electrification measures of the kind that that Wes has just discussed. So next slide, please. So it's sort of fortuitous that the title of this webinar is the ABCs of multifamily electrification. And I think in addition to the important considerations that Wes just laid out, we'd also like to think that ABC might stand for advanced building construction. So the advanced building construction is an initiative at the Department of Energy. Rocky Mountain Institute leads an industry collaborative that is focused on catalyzing the market for high performance and industrialized construction practices that have the potential to scale decarbonization efforts to levels consistent with our climate goals. So we sort of think of advanced building construction as the pairing of these high performance outcomes with a sort of industrialized delivery method. Next slide, please. So what can an ABC retrofit look like? Just to give a few examples, this is a project in Southern California completed in 2022, the Veracruz apartments that are low-rise townhouse-style apartments. You can see the existing condition in the upper right photo on the left side. And the ABC approach here was to seal up the attics in the apartment buildings and use these prefabricated roof panels that came inclusive of metal roofing layer and insulation that could then be laid on top of the buildings to greatly improve the thermal performance. And given the relatively mild climate in California, this coupled with window replacements and then electrifying the equipment help to reduce energy use and reduce the thermal loads to a point where the electrified equipment could operate efficiently and lower the impact of energy bills and whatnot that I think Jackie is going to get into more later. Next slide, please. Here's another example in a colder climate. This is a planned retrofit project of the Ravenswood apartment building in New York City. It's a New York City Housing Authority project that's being done in partnership with Retrofit New York. And you can see on the left side, the planned use of these prefabricated wall panels that are inclusive of insulation, all the control layers, and new triple pane windows that are planned to be installed over a prefabricated window surround box that you can see there in white. The panels also significantly improve the air leakage of the building through gasketed connections at the panel joints and window detailing. That new high performance envelope is then paired with electrified equipment that can be sized down because of the reduced thermal loads. And the whole building in this case, I think, is predicted to save something on the order of 75% of its existing energy use. Next slide, please. All right, so now I'm going to get into some of the details of this report that is aimed at providing technical performance guidance and cost targets that are really aimed at in helping to inform decision-making on both the supply and demand sides of the market. So helping building owners figure out what to do and helping providers identify the performance levels and costs that they should target with their products and practices. Next slide, please. So diving right into the retrofit guidance. Next slide. So we worked in partnership with 3 of the national labs to analyze these 4 upgrade packages across the entire residential building stock in the US. And so package 1 there is basically just an all equipment swap out, taking all the existing equipment in the building that consumes fossil fuels and swapping it for high efficiency heat pump equipment for space and water conditioning, and then appliance swap outs as well. We then looked at that same equipment package and paired it with 3 levels of increasingly aggressive envelope intervention. So sort of light touch envelope that includes about R6.5 continuous wall insulation and maybe a low E storm window over the existing windows, all the way through bringing the envelope up to compliance with IECC code, and then package 4, where we paired the same equipment package with a envelope consistent with the Passive House Institute US 2021 guidance. So next slide, please. So then we took the results of all of this analysis and we applied some logic to help us identify which retrofit needed to be applied where. And to do that, on the left-hand side of this graphic, you can see that we first determined which building segments did not need to be prioritized for any of the 4 retrofit packages because they were already high performing and on their way to being zero carbon aligned. We then determined which buildings required an envelope retrofit in order to achieve zero carbon alignment, and which could just use an equipment replacement. And then we determined how aggressive, if a building did need an envelope retrofit, how aggressive that envelope retrofit needs to be, while considering things like limiting the resulting HVAC system capacities to both reduce upfront costs and also mitigate impacts on the electric grid. We then took the results of those performance assignments and paired it with some market data about the geographic locations where these type of ABC solutions might be poised to scale more quickly. And then those segments are then described in the report. And I should note that resilience was not used as a primary assignment criteria and was mostly due to data limitations, but that resilience is a very key consideration, and in some instances a real driver of upgrades, which might lead you to higher levels of performance with the upgrade packages. Next slide, please. So given this assignment logic, we then assigned these retrofit packages to multifamily buildings across all climate zones, and these are the results by climate zone. So you can see that a good chunk of multifamily buildings receive just an all equipment swap out. That's all they need to achieve this zero carbon alignment, and that the bulk of the envelope interventions, which are the 3 packages in the middle, really are in cold and very cold climates and also mixed humid climates. And then that's overwhelmingly true for the higher performance envelope cases of IECC and FIAS levels. Next slide, please. These are the same results shown by state here that shows a pie chart of each of those packages that we analyzed applied to all multifamily buildings within each state. So you can see in a place like California with a relatively mild climate, we see a lot of multifamily buildings that just need an all equipment swap out, and then a good chunk that need equipment plus a conventional or light touch envelope. Whereas in a state like New York, where there are a lot of multifamily buildings, we see more of a mix of the light touch IECC envelope and then a slice of FIAS level performance as well. Next slide, please. So we then looked at what these package assignments would do in terms of utility bills. And so this is just a map showing the median utility bill savings by state for the assigned packages. So again, you can see in a place like California, where we're not going as deep with the envelope retrofits and the utility bill considerations there, the median savings is somewhere in the neighborhood of $133 per year per multifamily dwelling unit, with some standard deviation, which is the piece in parentheses there, but not huge, versus a state like Massachusetts, where the median savings is more than tripled, and there's a huge spread in terms of the standard deviation around how much utility bill savings we could expect with these retrofits. Next slide, please. Great. So some key takeaways for the multifamily market. Our analysis suggests that about 17 million multifamily units across the country will require an envelope upgrade in addition to electrifying its equipment. And this represents about 50% of the US multifamily housing stock. About 12 million of those units require a modest level of envelope improvement, and about 5 million, or roughly 15% of the stock, require these more aggressive envelope interventions to accompany the electrified equipment. And with that, there's about 17 million units, the other 50% of the stock, that do not require an envelope upgrade, either because they only require all equipment swap out, or about 12% of the stock that is sufficiently zero carbon aligned in the first place, or on its way to being decarbonized already. And then I think I already discussed those considerations about resilience. Next slide, please. So I think I need to wrap up here somewhat quickly. So I'm going to just highlight that there is an online decision tool that I think the link is on the next slide, that shows that allows building owners or anyone to go in and enter the location and characteristics of the building type, vintage, floor area. Next slide, please. Some information about the heating and cooling system, whether or not the building has ducts. Next slide, please. Some information about the enclosure with windows, existing insulation in the walls and ceiling. And then next slide, please. It takes in all those all that information about the existing characteristics, and then recommends a decarbonization package that is based on the analysis that I just described. And so this is a very useful tool that we're hoping folks will make use of to help sort of answer this question of like, okay, I want to electrify my building, I want to decarbonize it, but where do I start? How do I think about what needs to be done? We think this, we're hoping that this tool will provide a useful place to start. Next slide, please. And then we've also paired the tool with a platform called Build Exact that is actually able to, where contractors and distributors and manufacturers are able to upload products that can deliver the recommended performance levels, and that so that you can take the results of your building and then go click on the link and be directed to a platform that will help pool some of the delivery providers to help you achieve the recommended retrofit. And then I think I'm going to gloss over the next two slides just for the sake of time, but just highlight that in the report, we also, next slide, please. We also provide cost targets that are really aimed at industry for, next slide, please, for what we think these packages should target in terms of installed cost in via package and in these sort of priority states where we think advanced building construction solutions are sort of poised to scale in the market. So next slide. Thank you very much, and I'll pass it to the next presenter.
Wonderful. Thank you, Brett. So a quick reminder to our audience to send in any questions you have at slido.com with the event code #DOE. We look forward to answering your questions at the end of the session. And now we will hear from our final speaker today, Jackie. Jackie, take it away.
Thanks. Hi, everyone. Jackie here at Elevate. Let's kick it off in the slides. There's some slides that speak for themselves. Go ahead to the next one. And so I will try to keep us brief so we can have time for questions. If you're not familiar with Elevate, we are a mission-based nonprofit organization headquartered in Chicago with some local work happening across the country. We are seeking to create a world in which everyone has clean, affordable heat, power, and water in their homes and communities, no matter who they are or where they live. Next slide. On the affordable housing side of our work, we've retrofitted over 100,000 units over the past 20 years, and our programs also span energy and health retrofits, solar, demand response, dynamic pricing, and we're working on figuring out how electrification fits into this. So go to the next slide. Our approach is one that tries to focus equity as part of electrification. So we know we want high quality affordable housing, we want to eliminate fossil fuels, and we know that we want to work with communities that have been historically redlined or disinvested, and that end up being lower wealth, renters, seniors, and other vulnerable groups that are also more likely to live in old buildings and lack cooling, and disproportionately experience the effects of climate change, whether that's by heat waves or other climate disasters. So we're thinking about how building electrification retrofits shift energy costs and affect these groups, and also how we put them at the front of the line in access to resources and new technology in this effort to decarbonize our buildings. So I'll talk a lot about energy costs and savings in our case studies, and keep in mind when I'm talking about energy burden, that's when more than 8% of your income is in utility costs. And we're really focused on doing electrification in a way that does not increase burden for owners and tenants. And if it does, because we know that heat pumps and electrification measures are not always going to be energy efficiency and cost saving, we're looking for the ways to offset that. So next slide. The strategies we're exploring or testing right now are to always start with energy efficiency first. The two case studies I'll jump into have both been weatherized. And then we're looking at real data to be more exact and confident in what costs are going to look like after the work is done. We're looking at how fixed costs impact utility bills for customers and what it means, whether or not they're going to have one or two utility bills after the work is done. Where it's possible, we're looking at switching heat rates when and where area. That's something that we can talk to owners about, moving from an gas to an electric heat rate, and also considering how that is affecting tenants with light heat benefits and making sure that they're applying for the right space heat, this type of space heat. We're exploring solar, of course, so I'll talk about that in our case studies and how that offsets costs. And also in both scenarios, talking about how we're keeping some costs on the owner's central account and what that means. Operations and maintenance, and as well as long-term monitoring, all of this is very important. We'll talk about that in the lessons learned. So let's jump into the first case study. Next slide, which is in the Madison area. It's a small multifamily, affordable, naturally occurring affordable property. And we're looking at about $140,000 worth of scope. I'm going to break that down in the next slide, but just some highlights on that this is currently individually heated furnaces. We're moving to heat pumps. This is partial electrification. We're seeing partial and full electrification scenarios and exploring both to meet people where they're at, depending on what existing rates they have, what existing equipment they have, how new or old it is. But we're looking also at solar. And so the benefits are going to be reduced operating costs, zero heating and cooling costs for tenants, adding cooling for resiliency, as well as comfort. And then a good amount of reduction in carbon emissions and the opportunity to look at solar. So let's go to the next slide to break this down a little bit more. The scope here for heat pumps, electrical upgrades that are needed, we're seeing that is very common in the stock that we're upgrading. So service upgrades are going to cost, and solar all heat pumps, electrical and solar, are around $40,000 each, spread into as well as weatherization and a central DHW, domestic hot water heater upgrade. So we're offsetting costs by helping the owner with grants, and they're expecting rebates and tax credits. Next slide. So we'll talk a little bit about cost or savings here. So initially, they're looking at $2,000 in the annual costs and on the gas side, sorry, and then around $4,000 on the electric. After the retrofit, with the solar that we're designing and fundraising for, or helping the owner fundraise for, the savings is about 27%. Go to the next case study here. We'll move down to Chicago, where this is a typical multifamily stack where we've got a courtyard, masonry, 1920s, 1930s. This is 44 units across 3 buildings on the northwest side. Pre-retrofit, they had furnaces, stoves. So, and I'm sorry, I didn't mention, the last case study is in the design stage and moving towards construction. We have, proposals and grant agreements. And this project was completed last year. So this is the full electrification where we're starting to be able to monitor the equipment. It was a good candidate because it had received weatherization in 2013. So this building envelope had been already upgraded. And, we're partnering with Bickerdike Redevelopment Corporation, which is a great organization here in the Chicagoland area. Next slide. A huge piece of this is resident engagement and how we're talking to tenants about what this means, how it affects bills, what changes for them, how comfort will be impacted, and how things will feel for them. As part of getting folks involved, there were incentives in a community meeting, but incentives to get their feedback on surveys, and we'll be doing that in post-retrofit interviews as well. And again, paying attention to some folks were receiving light heat benefits, so we want to make sure they switch from gas to electric heat to still continue to receive those benefits. Next slide. I apologize, I did not put the costs in here, but this is the breakdown, and I can mention those later or put them in the chat. But overall, this is about a $1.5 million scope for heat pumps to replace the individual furnaces and water and window units. 3 heat pump hot water heaters that were central across 3 buildings to replace their old boiler hot water heaters, stoves across all units that were non-induction electric stoves now, and common area dryers. We are currently working with the owner to get solar in, hopefully in the next 6 months. But next slide, we'll talk about how that impacts the savings. So the owner will actually see an increase without solar, and they will install solar and then see a reduction. The residents will see a savings either way. And so that's great. And they've been able to experience cooling for the first summer, this past summer, and everyone was excited about that. 44% carbon savings here. And then let's jump to the next slide just to start talking about some of the lessons learned over the last few minutes that we have here. I definitely want to get into the Q&A on this. So overall, we're seeing, and I should also mention, we've done about 250 units across Chicagoland, Wisconsin, and Michigan so far. And some of the things we've seen are that you've also got to consider how ventilation may add to the load if it's not already working or sufficient. We've had contractors that have worked with building owners for years or decades that don't want to touch heat pumps. And so we've got to work to expand our network and bring new contractors in, establish new relationships across contractors and owners. We have to help maintenance staff along because they're going to be looking at new equipment. We've tried retrofitting one building out of a complex. So we may do 10, 15 units as opposed to 150 all at once. And this is a great way to test, get people used to things, but it's also another thing for maintenance staff to handle the operation of 2 different types of equipment. you have to center their experience in this process as well. It's very helpful, obviously, to schedule regular meetings, keep the communication flowing because we're learning a lot. Thank you. Everything varies by region. So even from Chicago, Michigan, and Wisconsin, we're seeing differences in rates and just experiences that owners have had. And again, it is about meeting people where they're at. We know that this is going to take time. We think it's very much worth the time. We've had to, go through reiterations of proposals with contractors and owners and presentations, and just being a part of the process has been really. It's important to think about heat pumps as not typical, at least in my experience in energy efficiency programs. This is not your typical furnace swap. We have to be really thoughtful about how we're looking at all the pieces together. And we're just really grateful for the owners that we're working with, because we have relationships with them that are either long-term. We've done insulation, we've done weatherization with them before, and now we get to test this new technology with them. Their partnership is invaluable. We could not be doing this without them. The last slide I have, one more slide, is just some other big takeaways that this has got to be integrated in all pieces of decarbonization. That's energy efficiency, it's solar. You saw in the case studies that we really needed solar for those two. There are other retrofits that might not, but you've got to model everything out, or look at the actual utility data to make sure we know what we're getting people into. And then it's going to vary by region because of utility rates or weather, or just how all the contractors are familiar with, especially cold climate heat pumps in our Midwest region. And so we know we're committed to working with manufacturers and assisting the workforce and bringing BIPOC contractors along. There are still gaps and work to be done. We have to, there are pre-barriers to installing heat pumps, like electrical service upgrades, which are seeing very commonly needed. And then we're just really excited to add cooling and other indoor air quality benefits to our customers, and continue working with building owners to figure this out. I will leave it there so we can jump into Q&A.
Thanks so much, Jackie. So we only have a couple minutes left for Q&A. I've noticed that some of the questions are about funding, from a very, very important question, either via utility rebates or the Inflation Reduction Act. For now, I would say one thing to know is that at the Better Buildings, Better Plants Summit in April in DC, which we have every year for the Better Buildings Initiative, we are having several different multifamily sessions that will touch on funding and financing, and specifically how IRA fits into that picture of financing deep retrofits and electrification. So please check, consider attending. Also, we have a financing navigator on the Better Building Solutions Center, which can be very helpful. And lastly, I'll say our page for the multifamily sector for the Better Buildings Initiative on HUD Exchange has a lot of resources available, so please check that out. So for the panelists, I'm going to try to focus on the top two questions we've had. First, what strategies have been especially useful in electrifying affordable multifamily housing?
I can say, again, focusing on keeping, helping the owner figure out how they're going to keep costs and offset costs, as opposed to move them to tenants. And then also a lot of layering of utility grants for solar, grants for heat pumps, and financing options, so that they have all the resources that can support that. I don't know if anyone else has anything to add. I'm also happy to talk about that if you want to contact me. Lots to discuss on that.
Yeah, I mean, I think multifamily housing, from what I know, it's always very complicated. It's always especially complicated because of the level of heterogeneity and in the buildings themselves and the building systems. And so it's always going to be more challenging for multifamily. And then with obviously with affordable multifamily, you're particularly subsidized. You have like that extra layer of challenge. But we're consistently working on this, and I do think that I welcome people to check out the Better Building Solution Center, where we have hundreds of different techniques posted and case studies for doing these kind of things. I do want to talk a bit about any tips the panelists have about addressing or getting around the split incentive between owners and tenants.
Could one of our speakers maybe define the split incentive, Josh, if you don't mind?
I can try, and I was muted, sorry. Obviously we're with heat pumps, especially in centrally heated or cooled buildings. If you're putting in heat pumps, there's definitely a chance you're going to be putting that cost on tenants. That's great for an owner to see a big cost reduction, but that does not work for the preservation of affordable housing and energy burden, which I mentioned. So one thing we're doing is just really trying to center the people, the owner and the tenants, and understand how their costs are impacted and help them by giving them all the the access to resources, whether that's rebates or grants, especially as we're all becoming more of experts in this technology. So they're helping us understand this, and we're happy that we can put them in touch with grants and rebates, and hopefully a lot more coming down the pipe with IRA.
We're seeing that a lot of the building owners are installing systems where they are putting like say the VRF or whatever type of heat pump technology they're using is on the central house meter, and because they're paying for if it was oil or natural gas to begin with, they're paying for 100% of the heating anyways, and the building might not be cooled or might be through wall AC, and half the buildings are house metered anyways that might be owned. So they're just putting in the VRF on a house meter and providing that to the owner, to the tenants, and then they will take the grant, the incentives and whatnot for their own, for the to offset the cost of the upgrade project.
So unfortunately, I have to wrap up now. So I will say I'm still seeing a lot of questions on IRA. If you have questions about IRA and how it's going to go down and how you're going to be able to access it, you can send me an email, and I will hopefully. So my email is joshua.m.geyer GEYER@hud.gov. I will. This is going to be a topic of discussion for years to come. So I will collect those, and anytime I have some more information that's specific to this, I can send that out to folks. So Alex, do you have okay. So just want to thank everyone for participating, for submitting questions, obviously to our panelists for the wealth of information. Let's see. So next webinar, we hopefully you'll join us Tuesday, February 14th, in a week for our next webinar titled "Design to Deliver Lessons Learned from Architects, Engineers, and Contractors in Zero Carbon Buildings." Join us for this webinar to hear from architects, engineers, and contractors as they discuss AEC and client barriers to routine design and delivery of zero carbon buildings, in addition to resources developed by the Better Buildings Design and Construction Allies that address the challenges. Next slide. Next, we are pleased to announce registration for the 2023 Better Buildings, Better Plants Summit is now open. The summit is being held in the heart of Washington, D.C., April 11th through the 13th. In addition to engaging in interactive sessions, attendees can look forward to plenty of opportunities to network with their fellow industry peers and experts, explore the session tracks, and book your accommodations on the Better Building Solutions Center. Next slide. With that, I'd like to thank again our panelists very much for taking the time to be with us today. Feel free to contact our presenters directly with additional questions, or if we couldn't get to your question during the Q&A period. I encourage you to follow the Better Buildings Initiative on LinkedIn and Twitter for all the latest updates. You can find our handles by our respective icons on the left half of the slide. You will receive an email notice when today's recording, slides, and transcript are available on the Better Building Solutions Center. Thank you, everybody.